So last time we looked at how to solve simultaneous equations by graphing them and finding the point where they intersect. And now we're going to look at a way to do the same thing, find the point of intersection, but without graphing. We're just going to do it algebraically. So let's start with the same problem we started with in the last video. Y equals 3x plus 4 and y equals negative 2x minus 1. So here's what you should notice here. If both 3x plus 4 and negative 2x minus 1 are equal to y, then they are equal to each other. If two things are equal to the same thing, then they themselves are equal. So here we could say that because they're both equal to y, 3x plus 4 is equal to negative 2x minus 1. And if we solve this, we'll get 5x equals negative 5, x equals negative 1. Now we have to find y. So here's how we can find y. We can take x equals negative 1 and change x to negative 1 in either of these two equations. So let's just take this first one here. If we change x to negative 1, we'll get y equals 3 times negative 1 plus 4. And this will be y equals negative 3 plus 4. So y equals 1. So the solution here will be negative 1, 1. So that was pretty easy because both of these equations are in slope-intercept form. But most of the time when you're given simultaneous equations and you're not graphing them to solve, they're not going to be in that form. So let's see how we do it if we're not starting in that form. X plus y equals 4 and y equals 3. This one's pretty easy because we're given what one of the variables equals right at the start, y equals 3. So then we just change y to 3 in the first equation. So we'll have x plus 3 equals 4, x equals 1, and the solution will be 1, 3. Be careful about which variable is which. X is over here, y is there, so x comma y is 1 comma 3. Okay, let's do another one like that. X plus y equals 6 and y equals x plus 3. So now we don't know what number y is equal to, but we do know that it is 3 more than x. So what we can do is change y in the first equation to x plus 3 because we know it's the same thing. So we can say that x plus 3 equals 6. We change the y to x plus 3. So we'll have 2x plus 3 equals 6, 2x equals 3, x equals 3 over 2. Now to find y, we just take x equals 3 over 2 and we put it back into either of these two. So if we take the second one here, we'll get y equals, change x to 3 over 2, plus, and then so that we have fractions with the same denominators, we'll change 3 to 6 over 2. So y equals 9 over 2. And the solution here will be 3 over 2, 9 over 2. So those are pretty simple. Let's add in something a little more complex. Now we have coefficients in front of all of the variables. So here we don't have what either variable is equal to, but we can find that out by changing one of these equations. So if you look at this one here, we have 2y by itself on this side. So to find y here, it's very easy. We just divide both sides by 2 and we'll get y equals 2x minus 3. And now we can change y to 2x minus 3 in the first equation. 2x plus 3 times 2x minus 3 equals 7. So we'll get 2x plus 6x minus 9 equals 7. 8x equals 16. X equals 2. And now to find y from this, we can put 2 into any of these equations here for x. So this one over here is probably the simplest one, so let's just use that. Y equals 2 times x is 2 minus 3. So y will be 4 minus 3, which is 1. And the solution here will be 2, 1. Alright, let's do another one like that. Okay, so here we have coefficients in front of everything once again. So how do we decide which equation we want to pick a variable to try to isolate? Well, if you look at the first one here, we have 4, 5, and 7. We're going to have to do some dividing because of the coefficients, and none of these numbers really are multiples of each other or anything. In the second one, we have 3, 9, and 21. These are all multiples of 3, so this is going to be a lot easier to divide. We won't end up with any fractions. So let's use that one, and we can solve for either x or y. So let's just pick x. So if we first move 9y to the other side, we'll get negative 3x equals negative 9y plus 21. And now we divide both sides by negative 3, we get x equals 3y minus 7. So now that we have what x is equal to, let's just put that back up into the first equation. We change this one, so we're going to put it back into this equation. And we'll get 4 times x of 3y minus 7 minus 5y equals 7. So it'll be 12y minus 28 minus 5y equals 7. 7y equals 35. Y equals 5. Now that we have what y is equal to, let's put that back in this equation here. Again, we can pick any equation we want as long as it has both x and y in it. So that when we change y, we'll just have x left to solve for. So we'll have x equals 3 times y of 5 minus 7. This is 15 minus 7, which is 8, so x equals 8. And the solution here is 8, 5. Three x minus y equals 4, and 5x plus 3y equals 9. So to decide which equation to use here, you see that we already have a coefficient of 1, well actually negative 1 including the minus here. But that means we don't have to do any dividing to solve for y. So let's solve for y in this first equation because we can do this quick. If we move the negative y to the other side, we'll get y. And if we move positive y, if we move the 4 over back to this side, we'll get minus 4. So we can have 3x minus 4 equals positive y. And just like that, in one step, we have solved for y. So now we can change the y in this equation to 3x minus 4. And we'll get 5x plus 3 times changing y to 3x minus 4 equals 9. So this will be 5x plus 9x minus 12 equals 9. 14x equals 21. X equals 3 over 2. Now let's take x equals 3 over 2 and put it back into any of these equations up here. Let's just pick this one here. It looks the simplest. We have 3 times x of 3 over 2 minus 4 equals y. So 3 times 3 over 2 is 9 over 2. negative 4, if we want to rewrite that with the denominator of 2, is going to be negative 8 over 2. And so y is going to be equal to 9 over 2 minus 8 over 2, which is 1/2. So here the point of intersection is 3 over 2, 1 over 2. Alright, now let's switch to something that is going to be in less of a standard format. You could probably see that the standard format from the problems we've been doing is something times x plus or minus something times y equals a number. That's what these equations have been set up in. But that is how you'll normally be presented with the equations, but they can of course be in a different format. But remember, with this substitution method, what we first want to do is isolate one variable by itself. So in here it's not necessarily harder because we just have this negative y here, and so that seems like that would be the easiest thing to isolate. So if we move the negative y to the left side, it'll become a positive y. So then let's move negative 3x over, it'll be positive 3x. We'll move the plus 5 over here, it'll be minus 5. And then the minus 1 already here is going to make it minus 6. So we get y equals 3x minus 6. So now let's put that into the other equation. Negative 6 times a y of 3x minus 6 plus 18x equals 24. We'll get negative 18x plus 36 plus 18x equals 24. Negative 18x plus 18x is 0, so we're left with 36 equals 24. And right away that should jump out to you as impossible. Two different numbers, and we have an equal sign here. So how did that happen? Well, this whole pair of simultaneous equations actually has no solution because we ended up with an equation here that is impossible. If you end up with something that's impossible after you've simplified everything, then this was just an impossible system to begin with. These are actually two parallel lines. Remember that's when you have no solution, when you have two lines here that are parallel. If we were to convert these into slope-intercept form and graph them, they would be parallel. Since they never intersect, there is no solution. Okay, so let's go back to something in a slightly easier format. Except here we have a fraction. But let's just leave that since we already have exactly what x equals. We can just put 5/3 y plus 2 for x into the first equation. 6 times 5/3 y plus 2 minus 10y equals 12. 6 times 5 over 3 will be 30 over 3, which is 10y, plus 12 minus 10y equals 12. 10y minus 10y is 0, and we are left with 12 equals 12. Similar to what happened last time, except this time this is true. 12 is equal to 12. So what happens here? Well, this actually means that because we're left with an equation without any variables, just true, that means that whatever numbers we put in for x and y, since they're both going to get eliminated anyway, no matter what we put in for them is going to work. So because of that, we have infinite solutions. Since we're left with an equation that is true, that has no variables, the variables don't matter. And since they don't matter, they could be anything, which is why there's infinite solutions. Alright, we're going to stop with that one. So, as always, for a lot of these things, there are times when you get infinite solutions and times when you will get no solution. And it is important to know how to find that. So this was only one of two methods for algebraically solving simultaneous equations. Next time we're going to take a look at a different method, the combination method.